So what next? Instantaneous speed. Let's talk about that a little bit. Instant speed. What would be instant speed? Well, we'll do the same exercise as what we did when we talked about instantaneous velocity. Let me get that. Remember what we talked about instantaneous velocity? You have to figure out the ratio when delta t is approaching 0. When it's about to hit 0, you figure out what the displacement is, a teeny tiny displacement, take the ratio and you get instant velocity. Well, you do the same thing for instant speed. You wait for delta t and try to make delta t approach 0. You try to take an extremely small time interval and figure out what the distance traveled is. You divide the two, you get 0 by 0 if you do a normal algebra, but you have to use some sort of calculus or something, and then you will be able to calculate what the instant speed would be. But what I want to know, or what we want to talk about, is how does it compare with instant velocity? What do you think? How does it compare with instant velocity? Well, again, it all boils down to displacement and distance traveled. We saw that distance traveled in general could be more than displacement, but what do you think happens when delta t is approaching 0? So let's take a special case. When delta t is approaching 0, that's how we write approaching. Okay, it means the delta t is not 0. If it becomes 0, you can't calculate, but this means approaching. We are in the realm of what we call as calculus, but never mind that. I'm pretty sure you can understand what I'm talking about. So what do you think happens when delta t approaches 0? You take at any instant you want. Suppose you are over here and you play the movie for an extremely short interval of time. What you would see is that Bob would have moved just a little bit towards the right, just a hair towards the right. In that small time interval, delta x and distance would be the same, don't you think? In fact, that would be the case everywhere. As long as you make sure delta t is approaching 0, you would always find that d becomes equal to delta x. Think about it. I don't want to discuss more about it. I just want you to accept that. But I want you to think about it later on. Why should that be the case? Well, just think about it. When can displacement be different than distance? Well, if the particle has time to turn back. But I'm not giving particle any time to turn back, because to turn back it takes some finite time, and I'm making sure my delta t is approaching 0. So I'm not giving any room for the particle to actually turn back. So in this case, distance traveled and displacement must be equal to 0 when delta t approaches 0. Therefore, we can now conclude that velocity, so let me just write it down, velocity is the same as speed. They are the same things when you talk about instant values, but there's one subtle difference. The difference is velocity has sign. So if you consider velocity without sign, that is speed. You take the velocity, you strip it off the sign, of the sign, and what you get now is the speed. So let me give you one example to clarify what I mean by velocity is speed is velocity without sign. Imagine an example where you have a wall over here, and there's Bob again. And I take Bob, let me take a blue colored Bob, here's Bob, and Bob is very close. I throw Bob towards the wall, he's going to hit the wall. The moment, at the instant when he's about to hit the wall, just before he is about to hit the wall, I calculate its instantaneous velocity or instantaneous speed, is the same thing, and I find out that it is 10 meters per second. That's before it just hits the wall. Then it hits the wall and it bounces back. Again, the moment it bounces back, at that very instant, I calculate what its speed is using some instrument, and what I find, it's again 10 meters per second, but this way. Okay, this is before bouncing, and this is just after, this just before and just after bouncing. Let's think about what happened to the speed and what happened to velocity. Well, speed is the same because the instantaneous speed is 10 before, instantaneous speed is 10 later, so the speed has not changed. But what about velocity? Well, velocity has changed because remember, velocity has signs. So you take one direction as positive, let's say you take right side as positive, then before bouncing the velocity was a positive number, and after bouncing velocity is a negative number. So initial velocity is plus 10, final velocity is minus 10. So velocity has changed. So that's what I mean by speed is velocity without sign. I will see you on my next episode. Stay tuned.